So what are we doing today?
I'm pulling up the link right now and I'll send it to you.
Okay. Something different than this other page.
Oh, no. Oh, yeah. Sorry. There it is.
Okay. All right. Well, let's see. Can I make this bigger? Yeah, a little bit. Okay.
Number 1 looks like a no.
Because
7 squared plus 3.75 squared doesn't equal the square root of 8. Or 8 squared.
8 squared.
Yeah, sorry. Long day.
Okay, how about number 2?
This one's going to need a little work. So C to D is 42. O to M, 17. Set that up. Half 42 is 21. So 21 squared plus 17 squared. The square root of that is 27. Okay, so then what is it meaning when it's saying CD is perpendicular? Is that what that is to OM?
Yeah, that's a vital part for the theorem. Trying to find it here. None of this is ever in the same order as what my book has it in. Just a second, and I will find it. All right. The theorem says is that in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Hold on a second. Okay. If those are perpendicular, then these are right angles, right?
Right.
So how would we find the radius, which is question A? They give us OM is 17. ON is 16. And they give us CD is 42.
So you make right triangles with them.
Okay.
So EN would be 42, or E to F would be 42 as well then, correct?
No. And in fact, one of the things the theorem says is that if this distance that's now 17 is the same as the other distance, then those chords would be the same. But clearly they're not the same distance, which means those chords are not the same length. However, the other thing is that when you draw a perpendicular radius to a chord, it bisects the chord. So
Right.
OM bisects CD. So how far is CM?
21.
All right. Now can you figure out the radius?
Yeah. The radius would be 27.01.
Okay. It wants it in radical form. So R is equal to what? Remember when you're solving a right triangle, the first word should be square root of?
Right. R is the square root of 21 squared plus 17 squared.
Okay, and that's what we want to give the answer as. Okay, what's 21 squared?
21 squared is 441.
And 17 squared? 289?
289. Yep.
So R is equal to the square root of 730. Again, I need to turn my camera off. I heard there was the biggest hack that's ever taken place in U.S. history has been over the last month from Spain. And the net result is that everybody's internet speed is slowed down. I wonder if that's what's going on with my system. I've been having troubles for the last month.
That'd be weird.
Yeah, that's why I've had to turn my camera off almost every time. Anyway, back to this problem. So if R is equal to 730, can we reduce that?
What do you mean by reduce it? Like,
well, they want the answer in radical. If your answer is not an integer, express it in radical form, which is fine, but we have to make sure we express it in simplest radical form. So, to determine whether 730 is in simplest radical form, let's determine whether it's divisible by any of the perfect squares. Is it divisible by 4?
I don't think so, no.
A number is only divisible by 4 if its last 2 digits are divisible by 4.
Okay.
Is it divisible by, what's the next perfect square?
Isn't it, what would that be? 9?
Right. We know that a number is not divisible by 9 unless its digits add up to something that's divisible by 3. In other words, 730 is definitely not divisible by 9.
Right.
What's the next thing we should check?
17?
16.
16.
We're looking for perfect square numbers.
Right.
Also not divisible by 16. Next one would be 25.
And it is, no, it's not.
Okay. 36. You see the pattern.
Yeah.
And this doesn't seem to be divisible by anything. 64. No, if it was divisible by 64, it'd be divisible by 16. So, I guess this is the square root of 730. That's the answer.
All right.
For the radius.
Right, and then you form another right triangle, and you do
Okay.
2701.
Well, hold on. Did
Square.
they give us EF? No, they didn't give us EF. So another right triangle. Oh, we know the radius. Excuse me.
Right.
Well, we now know that that's the square root of 730.
and then you do that squared minus 16 squared. Alright, and we get 473.54, and then we need to...
Okay, again, we want to put it in radical form. So how do we put it in radical form?
27, or the square root of 27.01 squared.
No. Here's what radical form is. If I'm solving for en, it's always the square root of something, because it's a right triangle. So it's the square root of the hypotenuse squared, which is 730, minus the other side squared, which is 16 squared, which is 256. So what's 730 minus 256?
730 minus 256. 474.
Which again doesn't look to me, I don't see any natural divisors of that. Not natural perfect squares. 4 doesn't go into 74. So it's not divisible by 4. It's not divisible by 9. It's not divisible by 16, I don't think. 474, no, because notice that if it were divisible by 16, it would also have been divisible by 4, necessarily. Right. So we don't really need to check 16. 25, no. 36, possibly, but I don't think so. I'm going to, at this point, guess that that answer is 474. It seems strange to me that they're giving you problems that have answers like this, but and they want you to give them in radical form, which means you can't just use your calculator. All right, and in the last part, find EF. Well, if Fn was root 474, what is EF?
Double that.
Okay.
So
what's that answer?
948.
No, you don't double what's inside. In other words, you have 2 of these. So it's 2 root 474. You see the difference?
Yeah.
The other one would actually be a much smaller number, because if I put this 2 inside the radical, it becomes a 4. All right. Find x in this figure is the triangle equilateral, isosceles, or scalene. Okay. Well, what equations can we write in order to find x?
I wasn't sure on this one.
How many degrees is the full circumference of a circle?
360.
Okay. So each of these 3 arcs have to total 360. In other words, it's not just 360 around a point. That's certainly 360. But the length of the arc length has to be 360. In other words, if I split it up into 3 pieces, these 3 pieces have to total 360. So what equation can I write?
360 equals, and would you do all those like 8 minus 10 plus 10x plus 10 plus 6x.
Uh-huh. Because those are the only three arc lengths that make up the circumference of that circle. So that's 24x, that goes away, and that goes away, equals 360, x equals 15. And so we found x. Now let's determine what kind of triangle this is. Well, let's figure out the angles. If x is 15, what is this? Hold on a second. Let me. So what's the measurement of this arc if x is 15?
Which arc?
QP.
Oh, alright. If x is 15, you got 8 times 15 minus 10. That arc would be 110.
And what's the measurement of PR?
PR 6 times 15. That would be 90, so it can't be an equilateral.
And what's the measurement of QR?
160.
Okay. And just a quick check, that's 250, 360 for the whole circle. So we didn't make any math errors there. Now what kind of triangle is it?
What were the options up there? 'Cause
Well, before we go any further, tell me what angle Q is.
Q would have to an acute angle.
Well, have you had the formula yet where Q is equal to half of this intercepted arc? So I know that Q is equal to 45.
No, we have not had that.
You have not had that yet? Okay. Well, we don't really need that information to solve this problem. You instantly knew that it was not an equilateral triangle. Well,
Right.
Is it isosceles?
Maybe.
Isosceles would require two equal angles.
Oh, then no, it's not.
Okay, which means it has to be scalene. And we'll get ahead of the game here a little bit with you. Here's the center of the circle, but angle R has to be half of 110. And angle P has to be half of 160. So there's the triangle. Now, before I confuse you, let me tell you the other main thing that we have when we intercept an arc. If the intersection comes from the center of the circle, then that's equal to 80. If the intersection comes from the edge of a circle, and that's 80, then this is 40. You see the difference?
Yeah.
All right. And those are the two primary things you want to remember. And if it comes from somewhere else, well, there's a way to figure that out also. But these are the two primary situations, where the intersection comes from the center, which is an equal arc, and when it comes from where it has to be on the circumference. And then this angle is half that. All right.
Okay.
I think maybe you have had that, because this next question would indicate that you have had that. because I don't think there's any other way to solve this next question. Based on the information that I just gave you, let's work out some of these measurements.
All right.
Notice that all of these lines intersect on the circumference.
Right.
Now let's see. Angle X is 150. WZ is congruent with YZ. WZ is congruent with YZ. And angle Y is 92. Find each measurement. The figure is not drawn to scale. Angle Z.
Wouldn't that be 150 then? Or no, it'd be half of 150. Right?
Well, first of all, let's know that arc YZW is equal to what?
YZW is equal to 92?
No, arc length YZW, starting from the top, go this way, all the way to W. What's that got to be equal to? That arc?
180.
No. Remember that this arc length is twice the angle. So that whole arc length's got to be 300.
Okay.
Because this intercepts it. In other words, when you're talking about an arc that's intercepted, go to the end of the line, there's one point. Go to the end of the other line, there's another point. The arc that gets intercepted by those two lines is YZW. And it's always twice whatever that angle is. Okay, if that arc is 300, what is arc YXW?
Well, we don't have that angle yet unless it's...
Well, we're going to get that angle in a second. But we can figure out that arc because there's two arcs. Remember, the total circumference is 360 degrees. Now we've got half of it with 300 degrees.
60.
So it's 60 degrees from Y this way to W.
Right.
What does that make angle Z?
30.
Arc WZ is what?
WZ. Is that half of... No. Couldn't be double.
Notice that there is no angle that intercepts that specific arc.
Right. So would it be...
Well, let's try to find some of these other measurements. What is arc XWZ equal to?
Double 92. So...
184. Let's see. Hold on a second. Oh, we know this third angle now because it's a quadrilateral, so they have to add to 360. So this has got to be 88. And if that's 88, what is it from X, Y, Z? What is that arc length?
176.
So if X, Y, Z is 176, Y, Z, W is 300, ZWX is 184. Let's see, what else do they want here? They want arc length WZ. Let's see. They said WZ was equal to YZ. So WZ equals YZ. So if I create that triangle, I know that that's an isosceles triangle. Let's see, they also want angle W, which we gave them. Angle W was 88. And they want arc WX, WX. So they've asked us for two of these arcs. They want arc WX, and they want arc WZ. Hold on. What math can we put together here to solve for that?
I don't know. I mean, it would cut 92 and 88 in half.
Well, let's start writing what we do know. We know that arc WX plus arc WZ equals 184. Right?
Yeah.
Okay, we also know that WX plus XY equals T. And we know that xy plus yz equals 176. So we have 1, 2, 3, 4 variables and 3 equations. And the last thing we know is that yz plus wz equals 300. So that is 4 variables and 4 unknowns.
Alright.
Which means I can...
Make sure I'm doing this right.
Well, I'm not sure I'm doing it the easiest way. I'm not sure how to do this the easy way.
Well, my question is, how are you getting what they equal? Because I think I understand it.
Well, okay, let's take the top one that I wrote. xy plus yz. xy goes from there to there. yz goes from there to there. We've already figured out that that's 176 based on this 88-degree angle.
Right.
Okay. The next one, yz plus wz. Well, yz plus wz, that's based on this 150-degree angle, so that we know that's 300. Using the
Okay.
same logic for the other two equations, I now
That's what I thought. I
have
just wanted to make sure.
I now have 4 variables and 4 equations. So despite the difficulty of solving that, I can solve it. It just would take a long time. We certainly don't want to spend the next half hour doing it. Kind of leads me to believe that I've missed the essence of this. There must be an easier way to solve that. I just can't think of what it would be. But if my life depended on it, I can always solve it this way. 4 variables, 4 unknowns. As long as you have 4 variables and 4 unknowns, you can solve for them. We solved for everything but XW and WZ. So those are the unknowns. There's a much easier way to do it. I know, here, follow me. If WXY is 60, which we know it to be, no, I don't know what XY is. No, I cannot think of an easier way to do this. This doesn't even necessarily go through the center of the circle. None of these would. It's got to have something to do with the fact that that's equal to that. That makes this angle equal to that angle. Which makes YZ equal to ZW. Has to be. YZ has to be equal to ZW, and since the whole thing is 300, they're both 150. So this is 150. I didn't need all these simultaneous equations. Here, let me erase all of these and make sure that you understand what I'm doing here. Okay, they told us that YZ was equal to ZW.
Right.
Okay, that makes this an isosceles triangle. That makes this angle that I've got the little angle sign equal to this angle here. Well, this little angle here intercepts the arc ZW. So I know that ZW has to be equal to the arc intercepted by this angle, which is YZ. So I am now able to say that arc YZ is equal to arc ZW. And since I know the whole thing is equal to 300, they both have to be 150.
All right.
Once I figure out that this one's 150, well, I know it was 184 going all the way from here to here, so this one has to be 34. XW. Yeah, that's a much better way to solve it. These can be kind of tricky, but these are kind of fun. I like these. I've got a number of geometry students that are into this right now, and it's definitely a little trickier than your average problem, but it's just a question of doing it in steps. So if angle A is 20, what do we know about this figure? In other words, there's a theorem that's based on a tangent line intersecting with a chord and this angle. What is that angle equal to?
That angle is equal to x, isn't it?
theta is equal to 1/2 the difference between the big arc BC and the small arc BD. Whenever they are intersecting outside the circle, know that you're going to have to subtract. In other words, it's this arc minus this arc. Those are the two arcs that got intercepted by that tangent line and the chord.
I can't see which arcs are when...
Well, BC, you can see the left side of the circle.
Right.
That's the big arc. The little arc that has to be subtracted from that is BD, or X, as is the case. So, if that's the general formula, let's solve. They've given us theta. Theta is 20 equals 1/2. The big arc, BC, is 88. Minus BD, or X, in this case. Now we can solve for X. 40 equals 88 minus X. Take the X on the other side, take the 40 on the other side, and you got X of 44.
Okay. Are you just putting 40 there to cancel out the half, though?
Yes. Not to cancel out the half. I multiplied both sides of the equation by 2.
Okay.
That canceled the half on the right side and made the left side 40.
Okay.
Okay, now let's find y. That's a little harder. There's this tangent line, and they want to know this angle y, which we'll call epsilon. Well, we don't really have... Yes, we do. Huh. Well, what can we do? Let's draw something to the center of this circle. A radius, which I know makes a right angle with any tangent line. So if I draw a radius up from that one, that's a right angle also. And I know, let me draw that line. Can you see these lines I'm drawing?
Yeah.
All radiuses are equal, so that's equal to that. Notice that if we can figure out this angle, we'll know epsilon.
Well, how do you figure that out?
This was 88. This was 44. What is CD? If this is 88, that's 44. The rest of that circle is CD.
Right, and it has to add to 360, doesn't it?
Uh-huh. So what's 360 minus 132?
288.
So CD is 288, even though it doesn't look like it. They really were not exaggerating when they said the figure is not drawn to scale.
Right.
Okay, so now we have the measurements of all of those arcs. What is this angle right here?
Half of 44 is 22. Or would it be half of 288?
Actually, the answer would be 144. Remember that when we have an angle that starts from the center and goes up, that this angle is always the same as this arc. That's 90, this is 90.
Right.
So if I know that arc CD is 288, no, 288 isn't right, 188. Right? 188, 360 minus 132 is 228. Which makes this central angle here
140.
No, it makes it 288 also.
It's coming down from the middle.
Can't be 288. No way a triangle can be 288. Think about this a second. Angle Y. Let's go back and look at this. That angle Y has to be the difference between the outside chord and the inside intercepted arc, which is 0. So that angle Y would have to be 114. In other words, if I have the following situation, and I have a tangent line, and then I have a chord line, well, this angle right here, angle Y, has to be this arc, the outside arc that was intercepted, minus the inside arc, and there is no inside arc. It's a similar situation as up here, only it's inside the circle. So I'm saying that if this is 228, which our model says it is, then Y has to be 114. It has to be half of this arc minus the intercepted arc. Notice what you can do in problems like this. If I made this thing not quite tangent, see what I'm drawing here in the upper left?
Yeah.
Well, I know this angle is this arc minus this arc, half of that. So let's just bring our tangent line down a hair where it's still not quite a tangent line, intercepts a really, really tiny arc. And now this angle is half this arc minus that real small arc. Well, now let's take it to this situation here where it really is a tangent line. Now there's no minor arc to subtract from it, which means it's just half of the big arc. So if this thing is 288, or 228 rather, this is 114.
All right.
Despite what it looks like there. I mean, we know that looks less than 90, but CD certainly doesn't look to be 228 either.
No, not at all.
All right. Find the diameter of a circle that has endpoints one of the endpoints is at 4, 4. And the other endpoint is at -10, -8. This is overlaying a grid. Something like that. And the only thing they're telling us is that that's the endpoints of the diameter. So, what's the distance of the diameter?
Do you subtract from it, or?
What's the distance formula?
Oh, shoot. That's, -10 squared minus 4 squared plus -8 squared minus 4 squared.
So the difference between the x-coordinates is 14. We're going to square that. Notice that it does not matter whether we make it plus or minus. And the difference between the y-coordinates is 12. So the distance is the square root of 196 plus 144 340, which is divisible by 4. Actually, it's divisible by, so that is square root of 4 times square root of 85, which is 2 root 85. So that's the diameter. What's the radius?
Half of that, so wouldn't it be 1, or just 85, the square root of 85?
Root 85. And what's the coordinates of the center of this line? What's the midpoint? What's the midpoint formula?
I don't know then.
Well, what's halfway between the x-coordinates? What's halfway between -10 and 4?
Oh, -6.
Well, -7. Oh, excuse me, my mistake. Let's go with -3. -3 is 7 units away from -10, and it's 7 units away from 4. And -2.
I'm confused there.
Okay, well, let's figure out how we get the midpoint between two coordinates. We know the x-coordinate is halfway between -10 and 4. Well, if I draw a number line, and I put 4 there, and I put -10 over here, how do I find halfway between those two?
Counting it out.
That's pretty much what I did.
Okay.
It's going to be negative 3.
Okay.
Okay? Now, the technical way to do it is you take the two coordinates, you add them, and divide by 2. Well, if I take minus 10 plus 4, that gives me minus 6, divided by 2 gives me minus 3. So if I do the same thing with the y-coordinates and I add minus 8 to 4, I get minus 4, divided by 2, I get minus 2. So there's the coordinates for the center of the circle. We've figured out the diameter, or the radius, is root 85. They wanted the radius. If your answer is not an integer, express it in radical form, which we have. Root 85 is not divisible by 4. It's not divisible by 9. It's not divisible by 16, 25, 49. It's in simplest radical form. And write the equation for this circle. What's the general equation of a circle?
The general equation.
X minus h squared plus y minus k squared equals the radius squared. Well, we just figured out what h was. H was minus 3, so this becomes x plus 3 squared. K was minus 2, so this becomes y plus 2 squared. And the radius squared is 85, because the radius was square root of 85. So here's the equation of that circle. To write the equation of the circle, you need the center and you need the radius. And then it will always go into this general equation. If you tell me the center is always h comma k, and r is the radius. So once I've found the center and the radius, then I can write the equation easily.
Okay.
See, I hope, how many more of these do we have here?
There's
Enough that I presume we're going to finish this on Wednesday?
Yeah.
Okay. So let's go as far as we can. When Hero has to leave the house for a while, he tethers his puppy to the corner of a shed in the middle of his large backyard that is 10 foot by 7 foot. Okay, so I'm going to draw a rectangle for his yard. This is 10 foot by 7 foot. And he tethers to the corner of a shed in the middle, right there. The tether is 14 feet long. Well, that tether doesn't do any good. He might as well not have his dog tethered at all. If the tether is 14 feet long, the circle is well outside the yard. Right?
Right.
To the corner of a shed in the middle of his large backyard that is 10 foot by 7 foot. The tether is 14 feet long. He must have made a mistake, because that means the tether can go out to 14 feet in a circular direction, which means that the dog, if the yard wasn't there, the dog could go in a 14-foot radius from the middle of that yard.
Right.
Sketch the locus of points in the yard that the puppy can reach. Well, if we want to write the equation of this circle, we're going to assume that the center's at the center of our grid, and the equation would be what?
At the center of the grid
Is 0, 0.
Right.
So we know it's x minus 0 squared plus y minus 0 squared. And what's the radius of the circle?
14.
14 squared is 196. So there is the locus of points that the puppy can reach. And what this defines is the circumference of the circle. This is a very strange problem. I think it's a misprint somewhere. Don't think they meant to give us a backyard that was smaller than the tether in all directions. What would the point be? You know what I'm saying?
Yeah, I don't know.
You're not going to tether your dog so that he can get out of the yard. You're going to tether him so he has to stay within 14 feet of his circular post.
Right.
Now, it's possible that they meant the shed was 10 foot by 7 foot. In other words, maybe this is the shed here, and this is 10 foot by 7 foot, this upper quadrant, and he can go anywhere from this point on the circle to all the way around to the top part. But that doesn't make any sense. That would be a much harder math problem. All right, let's go on. Wow, their degree of difficulty really got hard. Is this new material here, or is this review?
This is supposed to be review for our big test on Thursday.
Okay. Okay. The chain fits tightly around 2 gears. There's one gear. There's another gear. There's the chain wrapped around all the way. It's wrapped around this outside of that gear. Okay, the distance between the centers of the gears is 20 inches. So from here to there is 20. The radius of the larger gear is 11 inches. Find the radius of the smaller gear. Round your answer to the nearest tenth. The diagram is not to scale. Oh, and plus it had information on it they didn't give us. That thing is 19 inches. This is 19 inches here. Okay, and they want the smaller radius.
Huh.
You think about this for a second. Let's pick this one up next time.
Okay.
Unfortunately, don't have time to finish this problem at the moment.
Right.
But since we're going to continue on, we'll continue on with number 8
All right.
on Wednesday.
Alrighty.
Okay, Ryan, I will talk to you on Wednesday.
All right.
Bye-bye.